wait is over. Let us start and begin. Good morning, participant, industry experts, and our valuable customers. Myself, Dhananjay Morishwar. I am your host today for this webinar. I am looking after the business development at Instron Technologies and bringing the 20 plus years of experience. My expertise in strategic partnership for mutual growth results. So we welcome you all to the webinar on smart energy audit, decarbonization with efficiency, designed specifically to understand how smart audits help you to achieve your decarbonization target with improvement in production efficiency. We would like to thank you all for taking your precious time to attend this live webinar. We also would like to thank Sneha and team for organizing this webinar and bringing all of us on this platform to share and discuss the knowledge on decarbonization with smart assessments. In this webinar, we will hear from specialist energy and sustainability partner who are also joining for this webinar. The webinar is focused on the real-time case studies, which helps to understand latest techniques for improvement in production efficiency with decarbonization. One interesting highlight of this session is sustainability portfolio, which enables customers to achieve their decarbonization targets. I'm sure you all are eager to hear from today's speakers. We will have a question and answer session at the end. You can also send your question in the chat box. Before we start the session, we will go through the Instron Technologies overview, strength, and through the corporate video.
We at Instron Technologies deliver our products and solutions for domestic and international customers, for manufacturing industry, for process industry, and also research laboratories. And we could do this because of our in-house cross-domain expertise, rich experience, and dynamic team. Hello, I'm Milind Saindabe.
Hi, I'm Rafi Bokhre.
Hi,
my name is Rahul Shirude.
I have 19 plus years of experience into research, new product development, and Internet of Things.
I have more than 2 decades of experience in process engineering, automation solutions, and new product development. With me, I bring 13 years of experience in automation and IoT new product development.
Instron was incorporated as a proprietor firm in 2013 and Instron Technologies LLP was formed in 2016. Based out of Industrial Hub of Pune, Maharashtra. We have served 200 plus reputed clientele and now we have incorporated Instron Technologies Inc. in Canada to serve the North American market. This makes us MNC with Indian origin.
Instron Technologies offers products and solutions into 3 verticals: process plants, digital factory solutions, and test bench systems.
In process plants, we help customers right from conceptualization to detailed engineering and also complete plant supply and installation. In digital factory solutions, we help customers monitor their critical parameters on the go by offering systems right from sensors, communication with existing PLCs, and then giving authenticate data to empower the decision makers. And in test bench systems, we provide end-of-line and performance evaluation test benches for, say, electrical motors, appliances like refrigerators and ACs and thrusters, etc. Our strength is our in-house expertise in automation, IT, chemical processes, and mechanical design. We leverage it to discover unmet customer needs and provide turnkey tailor-made solutions. Our solutions have helped clients to enhance their production and efficiency to achieve their sustainability goals. Our mission at Instron Technologies is to continuously innovate and enhance operations for customers globally in the manufacturing industry, process industry, and research laboratories. Our vision is to become a recognized leader in specialized products and solutions, particularly in process plant systems, digital factory solutions, and test bench systems. We aspire to make substantial contributions to enhance productivity and efficiency for our customers. We have been recognized as one of the 10 most promising industrial IoT solution providers. We are ISO certified, and we also got selected for DRDO Technology Development Fund and IDEX initiative. With this, we look forward to expand our presence in Canada, Australia, Sri Lanka, and Thailand. We have developed a young and dynamic core team and execution teams to help achieve the organizational goals. We strive to achieve the philosophy of growth at individual level and also at organization level. And because of this, we have leaders in our organization for day-to-day decisions.
Thank you all for your engagement during the corporate video segment. We hope you found it insightful. Instron Technologies' mission is to foster and sustainability across the manufacturing and R&D sectors. Our motto, "Let us grow together," reflects our commitment towards collaborative working progress. We assist customers by conducting audits and assessment for all types of energy, highlighting potential savings. We assess plants from the perspective of air audits, thermal audits, electrical safety, and electrical compliance. In addition to energy assessments, we also perform digital infrastructure assessments of the shop floor to develop a digital transformation plan for efficient data monitoring. The digital maturity assessment evaluates the current state of digital maturity in the manufacturing industry. It focuses on process optimization and adopting latest technologies. This assessment emphasizes IoT-based principles such as real-time data monitoring, OE monitoring, traceability, predictability, energy monitoring system, and increasing productivity and process efficiency. This is aimed at digitizing overall manufacturing operation and utilities. We don't just provide reports showing potential savings. We also partner with customers to implement the recommended changes. This makes us a one-stop shop for our customers. Now, after understanding the background of the organization and its credibility, especially into sustainable solution, moving on to the next session, I would like to introduce our next industry expert speaker, Mr. Milind Sandane, Director and co-founder from Instron Technologies. Milind bringing over 20 years of expertise in energy engineering, IoT technologies, and new product development. This seasoned business leader excel in driving profitable revenue growth and resource optimization through energy and process audits. Equipped with MTech in energy systems from IIT Mumbai, possess extensive knowledge of cutting-edge technologies. We also shared Mr. Milind's LinkedIn profile in chat box for more details. Over to you, Milind, energy engineering leader.
Thank you, Dhananjay, for such a nice introduction. Good morning, participants, my fellow speakers, and the organizing team. I observe from the profiles of the participants that we have CEOs, presidents, plant heads, and key decision makers from manufacturing, pharma, chemical, and research institutes. And we all speakers are trying to share something meaningful for all of you during this webinar. So in today's session, we'll be speaking on decarbonization, what is the real need, some basic knowledge on compliance and ISO standards, and finally would be summarizing with the real world industrial case study. So decarbonization has become a most talked about topic, just like an IoT or Industry 4.0 couple of years back. However, I thought of starting with the definition of decarbonization, considering the audience that we have right from the freshers to the very experienced seasoned business leaders. So decarbonization is an initiative to reduce CO2 emissions by improving your operations to achieve a lower output of greenhouse gases into the atmosphere. Greenhouse gases are responsible for global warming and harmful effects. Now, the most important question is how global warming is measured. We all must be hearing one number from various medias, and it's 1.5 degrees C. Let me tell you the background of this. In 2015, many nations signed COP21 agreement for climate change in Paris, all these nations agreed to one statement, which is hold the increase in the global average temperature to well below 2 degrees C, above pre-industrial levels, and pursue efforts to limit the temperature increase to 1.5 degrees C above pre-industrial levels. So as you all can see that pre-industrial levels and temperature measurements are an ambiguous words here. Different forums were using different references to pre-industrial levels, and now mostly acceptable period is 1815 to 1900. And the mean surface temperature is the long term, typically like 30 years average temperature measured on the surface and also 4 meters above the land and water, so that you can see there are many gray areas in the benchmarking itself and evaluating whether 1.5 degrees C has reached or not. Okay. And now let's see how close we are to this magical number of 1.5 degrees C. As you can see from this image that from one of the estimates with some assumptions, we'll be crossing this global mean average temperature rise by 2040. However, if we look at the momentary readings, then we had already crossed this in September 2023 last year itself, and this year also. But as you can see from the definition, it's a long-term average, which is 30 years average. So yes, we are still saying that it has not crossed, but yes, momentarily it had crossed. So with this slide, I want to leave with some thoughts on the gray areas in referencing and the reality of the present situation. Over the period of last few months and during my travel across the world, I have talked to many key decision makers about their views on the need for decarbonization. There were mixed reactions from skeptical to the positive ones. Now, I just want to know few of you from the industry, like what are your views on the need for real decarbonization? Is it really needed, or it's just one more initiative to keep all of us busy? I'll be happy to hear few views from the speakers. You can unmute yourself and share your thoughts quickly. So this is just to know like what we think about the decarbonization. Is it really needed, or it's just a kind of one of the thing which is started by the Western world and we all are falling into the trap? That's the kind of views that I had been hearing. So I'll be happy to hear if you have any views about this.
Hello, sir. This is Sangesh Suryavanshi. Yes,
Hello,
sir.
sir.
It is actually needed because average global temperature is increasing day by day, and to control it, to mitigate this temperature rise, we need decarbonization.
Okay, great. Thank you. Thank you for sharing the positive views.
Yes.
I'll be happy if there is anyone who sees this as not needed, or just to hear some perspective on that side of the wall as well. Is there anyone in the audience who believes that it is not needed?
So I support the need for control on that.
Okay.
I wrote an article on LinkedIn
Yes.
a short while ago about a story. In 2008, I visited the glaciers in Alberta, and it had already receded. And I have a photograph there that I showed where it was. And today, it is even further receded. So the glaciers are disappearing. With the heat, the ice is totally melting.
Right.
The same thing is happening up in the north coast of India, of Canada. The icebergs are all melting.
Great. So yeah, thanks Mustafa for sharing this first-hand experiences about the global warming. So yeah, so here what I see is all the audience is positive, and that's why we all are here, I guess. But let me share my views on this. So I tried to search some recent events in and around us and found these two relevant cases. There are many, but I thought of sharing this too, considering the time restriction. And this has affected few people that I know personally. As you can see, flights couldn't take off from Leh as the air was less dense due to a higher temperature. We all know that Leh is supposed to be coolest in the country, and we can see what's happening there. And another example is the effect on preterm births because of the emissions and global warming. So I believe that these are enough reasons for all of us in the industries to believe that global warming is really happening. It is affecting our families, our neighborhood, and the country. So we at leadership level must do something to reduce global warming. And we want to share some ways in which it's not just the cost, but also an attractive proposal. So there are compliances by international companies to commit on the decarbonization, and it's defined in detail in ISO 14064. You can see that the CO2 is one of the GHGs, as can be seen from this image. And there are initiatives for reducing all of this. Today we are going to talk about the decarbonization of the emissions are classified as the direct and indirect emissions generated from the industrial activities. So direct or the scope 1, which is also called as the scope 1, are the emissions generated from burning fuels within the battery limit of the organization. Whereas the indirect emissions are emissions generated outside the battery limit, but are required for the operation of the organizations. These indirect emissions are categorized under scope 2. For example, electrical energy used for operating machines, but it is produced somewhere outside the factory. And the scope 3 is like a travel or logistics related emissions from upstream and downstream activities. You can see few examples from these images. Now moving on to the next slide, where to understand this, let's take an example of an aluminum die casting industry with the processes like melting furnace, die casting machines, machine centers, paint shop, and finished products. This comes from one of our smart audit assessment and also an implementation in the real world. As you can see, the scope 1 emissions are to be measured for the fuel burned inside the furnace for melting the metal. You can notice an emission factor to convert the fuel consumed to CO2 generated. This is a scientifically calculated number. So for example, LPG is composed of butane and propane, having a carbon as one of the components. So there is a specific amount of CO2 generated from this butane and propane components, and that's how this conversion factor has arrived. By the way, these factors are defined for different types of fuels, different locations and applications also. So for example, this factor is different in India and US just because of other emissions associated with supplying this every kg of the gas to your premises. So as you can see, for the measured amount of fuel consumed for 2 furnaces, we could convert it into the tons of CO2 per year. And here the furnace 2 is more efficient and green as compared to 1. Similarly, the scope 2 from the power consumed for operating machine centers is shown for line 1 and line 2 of this particular customer. And you can see that the line 1 is greener than the line 2. So you see the context is changing. Earlier we were talking about the efficient. Now along with efficient, it is the greener also we are talking. One more interesting case from this change in the context or the approach because of the decarbonization initiative. For a pharma company, earlier the customers would consider low investment or ROI less than 2 years for immediate implementation from our audit findings. However, now CO2 is the number attached to this savings. And because of this, we have seen that earlier proposal number 3, which is the biomass conversion, which was never considered, was given the last priority. is now being considered a special initiative. This is just because of this magical number of the CO2, which is like 5,700 and odd tons of CO2 generated from this one single source. So this is also another example of the changing context. So moving on to my final point on how we do the smarts assessments differently. For any organization, we do the need finding audit to identify the pain areas, and through that we propose the system which will help customers realize the benefits. This usually starts with the IoT-based monitoring system. We don't leave the customers here, which happens with the other suppliers of the IoT systems. We do quarterly data analysis and walkthrough audits for these installations, which is part of the basic package. This joint effort of analysis with the customers' teams points towards implementations for improvements, like the combustion fine-tuning, melting, set point fine-tuning, servo drives instead of induction motors, and many things. So analysis from one such case can be seen here. We could do the real-time individual machine-level energy efficiency benchmarking instead of the earlier plant-level daily analysis. This is possible because of the IoT-based system connected to different sensors, energy meters or gas flow meters, and machines. For this case, we have evaluated the potential monetary savings of 15 lakhs per year, and that will also reduce the footprint, CO2 footprint by 30 tons per year. So isn't it an attractive proposal? So this is how we, as an alliance of Instron Technologies, Efficomp, SAS Technologies, along with the Siemens, do this smarts assessments differently. So with this, I would like to conclude my part of the session, and thank you for listening patiently. And we can take some questions toward the end. Thank you, Dhananjay.
Thank you, Milind, helping us to understand about use case of decarbonization with efficiency. Now, let us move on to the next session. I would like to introduce our next industry expert speaker, Mr. Dhirendra Shukla, entrepreneur and principal consultant from Efficomp Air and Energy Consulting Services, bringing 20 plus years of the compressed air. Next slide, please. He is a Bureau of Energy Efficiency India certified energy manager with 300 plus audit experience. Mr. Dhirendra was awarded as the best presenter BBS Air Tech seminar on compressed air system topic. Efficomp Air are a professional energy consulting company specializing in compressed air system audits and solutions. Their services are end-to-end solutions for identifying saving opportunities in systems, which are achievable with or without investment. Their company has a record of achieving over 40% saving during audit without investment. In total, has worked to save around 16 million units worldwide. We have shared Mr. Dhirendra LinkedIn profile in the inbox. You can go through that for more details. Over to you, Dhirendra, air engineering leader.
Thanks, Dhananjay, for such a nice and brief introduction. So, to start with, here is a representative drawing of a compressed air system. So, as our fellow speaker spoke earlier about carbon reduction. So, generally, whenever we look for carbon reduction, our main focus goes directly on fuel, or rather, you can say emission reductions. But we generally don't focus on the other electrical aspects where actually the electricity is coming through a source which may or may not be properly managed system. So any reduction in electrical side at any plant is a direct reduction of CO2 at the generation source. There is a saying that 1 unit saved is equivalent to 2 units produced. So here, compressed air as a system is one of the least efficient utility of any plant. This representation shows you that when we put in 8 HP of electrical energy in the compressor, we get around 1 HP of equivalent compressed air power. So by default, this compressed air system by design is an inefficient source of energy. So if we are not managing it properly in any plant, our you can say efficiencies are very much affected. So compared to other utilities of steam, electricity, and water, compressor has the least operating efficiency. It is one of the second most critical utilities of any plant. Utility knows the cost, but production, whenever they are trying low pressure or anything, generally utility adds up more compressor in the system rather than looking at the issues. And adding up more compressor does not solve your issues. But utility knows the operating cost of the system. And there is a terminology, and if you look at other utilities like steam, HVAC, water system, if there are any leakages or anything, people tend to attend to those very precisely. But whenever people pass by and see loss of compressed air, so there is a famous terminology used that air is free. That's why people think that compressed air is also free. But as I said, it is the most costliest utility of any plant. So if you see any loss of compressed air in any plant, any misuse, any leakages, you rather focus more on compressed air, rather you prioritize that. So the main reason for people not focusing on compressed air is they actually not knowing the operating cost of the system. So here is an example of compressed air, a simple 250 kilowatt compressor running at a industry or a simple plant. You can look at a value of 5 rupees per kWh per unit. The running cost itself comes around 1 crore. So whenever we look at any plant, generally who are more than 250 kilowatt, we generally I have seen plants more than 10 megawatt of operating efficient connected load of for compressed air systems. So a single 250 kilowatt compressor can generate an equivalent to 1432 tons of CO2. So any reduction, you can imagine the value of carbon added in ambient conditions or atmosphere because of compressor operation. So we should also know the operating cost and then manage it accordingly. So compressed air, we generally, whenever we look at compressed air system, we generally focus only on the supply side. But whenever we look at any other utility, we look the overall system as well. We look at distribution as well. We look at how they are consuming. But for compressed air, generally people are more focused on the supply side. But compressed air system, as compared to any other utility, should also be considered as a system, and we should focus on supply, on distribution side, as well as the demand side, where the actual consumptions are happening. So when we say what is the demand percentage and usage percentage scenario in any industry. So if you see the graphical representation of the same, out of the total generated capacity in a compressed air system, this is mostly likely for most of the industries. So compressed air leakage is one of the big culprit for overall system demand. People generally, as I said, don't focus on the leakages, which form as high as 20% of the total supply. There are some terminologies called as artificial demand, which are as high as 15% of the total supply, and then inappropriate usages. So in totality, if you see the graph, we can summarize that actual productive demand is around 50% of the total supplied values. And when we focus, we have a big margin for reductions in compressed air system as a whole. Similarly, when we look on distribution network, over the period, distribution, whenever plants are designed, distribution systems keep on adding rather than remodifying the complete system. And generally, whenever we plan a new system, what we do is we generally focus on the primary investments on the investment on the pipings and other areas rather than focusing on the efficiency of the system as a whole. Here is an example. So whenever we see, whenever a new piping is laid out, generally, if you see a 3-inch piping generally costs lower than a 4-inch pipe. So there was a system designed to carry for 2000 CFM. The purchase department will say that, oh, if it can be done with a 3-inch pipe, why to go for 4-inch pipe? We will be saving 6 lakh rupees for the same comparative value compared to a 4-inch line. But if you see the operating cost in a year, because we know smaller the line size, smaller would be higher would be the pressure loss. So with a 3-inch line, there would be a 15 psi drop in a system, and with a 4-inch line, the drop would have been only 4 psi. So if a user which is at the end of the line requires higher pressure, then unnecessarily you have to increase the pressure at the generation at the compressor house. And there is a basic thumb rule in compressor system that for every 1 bar excess pressurization, that is 14 psi, compressor power increases by 7%. So in correlation to that, 11 psi increase, which may be required with a 3-inch line, would cost you around 13 lakh rupees in a year. So who was smarter? The purchase guy who saved 6 lakhs rupees initially selecting a 3-inch line in place of a 4-inch line, or a person who has installed a 4-inch line and then saving 13 lakh rupees year on year. So these are some basic systems which acted upon precisely or audited regularly, they can save a lot for the industries. You can see the amount of carbon reduction value shown here as 173 tons of CO2 only by increasing the line size, or rather installing a bigger line size compared to a smaller line size. Another example of compressed air system CO2 reduction is heat recovery. Generally, nobody knows, or rather, most of the people don't know that compressor, as I said earlier, that compressor is one of the least efficient utility. The main reason of that is whatever air we get at the output is only 15% of the electrical energy what we have given at the motor side as 100%. So around 7 HP is lost during that activity. That 7 HP is actually being lost in heat. So that heat, if we recover, we can know the value, how high it can be. With compressed air, if heat recovery is done, we can use it to preheat water for boiler or any space heating or any other industrial purpose where we want hot water up to 80 degrees centigrade. So heat recovery is one of the biggest area for CO2 reduction. Definitely, it will not affect on the compressor power, but it will have a direct impact on your fuel, which is being used for, rather you can say, steam. If you are using steam for heating purpose or water for other purpose where you are using electrical heaters, can be done with compressor itself. So it is one of the major areas of CO2 reduction in a system. Similarly, there is a device called demand controller. So where we generally don't control pressures in plant. So if one user requires, say, 6 bar in a plant, overall most of the areas in the plant which may require lesser pressure also, say 4 bar, they are also being supplied with higher pressure. So whenever we are supplying higher pressure, we are giving, we are increasing leakages in the plant at the same time, because higher the pressure, higher will be the leakages. So with this demand controllers, which are simple devices, we can control the supply pressure to those specific areas precisely, and this can also help decarbonize very effectively. So when we summarize on the slides, we rather focus on compressed air as a system rather than looking only on the generation side. There are opportunities available at each area in the plant, and our focus should start from the demand side rather than just from the supply side. So a demand reduction, then fixing on the distribution losses, and then finally moving to the generation side will help us decarbonize the system very effectively. Here are a few examples, case studies, which can be seen here. So as in say case, this is a live example where we did this in a pharma industry, where they are using hot water for their HVAC system for maintaining a precise temperature at the production area. So generally they were having a steam heater which was heating that water say around 40 to 45 degrees centigrade. We identified this and after this installed a heat recovery unit on the compressor, which is generally running 24/7 or 365 or other 350 days in a year. With this compressor, we were able to fulfill their overall plant demand and their complete steam, which was being used earlier for heating water, was replaced or rather actively extracted from the compressor, and we were able to reduce around 383 tons of carbon dioxide emission, which is which in terms of rupees, if you say, it's a big value around 27 lakh rupees just by recovering heat from the system. So this is one of the greatest area in any plant to recover heat from a compressor. Similarly, system monitoring and system optimization, where manual interventions are there. And generally, this is example of a beverage plant where shift batch changes, shift changes, compressors were kept running, lot of loading and unloading happening, no monitoring on the efficiencies of the compressor. So we installed a system wherein a complete compressor network was operated automatically through our system automation. No manual interventions were taken, and in totality, when we see the overall reduction on the operating power, it was around 50 lakh rupees and around 42 tons of CO2 was saved in the system. So if we summarize, compressed air is one of the least efficient utility, and it is one of the most easiest area to save in a plant. So our focus should also be on compressed air system as a energy as well as CO2 reduction. With this, I give this my presentation and allow Dhananjay to take it further.
Thank you, Dhirendra, for your nice insights on the compressed air, which is you have said correctly, it is the least efficient, but you made it very attractive. Thanks. I request all the participants who joined directly without registration to put their mail ID on the chat box so that we can connect them and share this recording and insight on their mailbox. Now, our next speaker, that is Mr. Abhijit. Electrical energy, which is the lifeline of industry and play important role in carbon footprint globally. So let us understand more about this from industry expert speaker, Mr. Abhijit Govind Katre, CEO and MD from SAS Powertech. With 26 plus years of experience in the field of power, electronics and electrical systems. Mr. Abhijit is MBA grad and expert in electrical system reliability and uptime enhancement. About SAS Powertech, it is an independent agency based out of Pune and helping its customers enhance their electrical system safety and reliability by achieving compliance to applicable electrical safety standards. SAS Powertech has conducted 1,000 plus electrical audits for clients, not only in India, but also globally. SAS Powertech is a licensed ETAP software user and undertakes power system studies for a greenfield project as well as brownfield projects. We have shared Mr. Abhijit LinkedIn profile in chat box for more details. Over to you, Mr. Abhijit, electrical engineering leader.
Thank you. Thanks a lot, Dhananjay, for this introduction, and I welcome all participants of this webinar on behalf of Team SAS Powertech Private Limited. So, as both my expert colleagues have mentioned, Milind and Mr. Dhirendra, about the necessity and need of smart assessments for aiding decarbonization initiatives and its associated benefits. So today it is more of a necessity rather than an option available with the industry. I would take this ahead a bit and in a different way, where I would like to highlight the necessity of having a reliable and a robust electrical infrastructure for ensuring that these initiatives that are started for decarbonization operate without break and deliver their necessary results to achieve your sustainability goals. So what is the importance of a reliable electrical system in decarbonizing in working facilities? So first of all, decarbonization goals are typically chasing net zero emissions, promoting sustainability for business processes, and enhancing reliability of existing infrastructure and useful life of assets. So that decarbonization is not just associated with the production, but even replacement of your existing assets. So if you're replacing an asset, the carbon emission associated with that also needs to be validated. So it is better to enhance the reliability and life of your assets that are already installed with you. Now, what exactly is the role of an electrical system in helping or achieving these things? So you all will agree that electrical systems or electrical infrastructure is the backbone of all business processes, may it be an industrial process, may it be an IT process, may it be any other activity that is associated with production. So it needs higher reliability. Higher reliability is essential for ensuring operational efficiency of any process, or it is data or any other thing. Enabling smooth integration of renewable energy typically also needs a very good, reliable electrical infrastructure, a supportive infrastructure that can integrate the generated power into your system. A lot of facilities have already switched to partial solar generation through rooftop solar plants, which is integrated into their day-to-day operations, where it is necessary that the electrical infrastructure should be operated. I will now share some case studies where electrical infrastructure has to cater to load current requirements continuously and the fault currents and short duration without getting damaged. If this is not achieved, one can expect catastrophic failures resulting in huge loss of property and life and fire and explosions also. The importance of electrical systems in decarbonization is also about their reliability and safety. So it is not just the reliable operations, but the safe operations of the electrical infrastructure that bring in a lot of importance to this complete concept. Replacement of infra assets in carbon intensive and increases carbon footprint. As I explained in the earlier slide, that if you are replacing any component, it doesn't mean that by an efficient system. That doesn't mean that you're actually bringing in a lot of saving, because you have to consider the carbon emissions lost during the production of that equipment or that component. Loss of property and life resulting huge social and governance turmoil. We have experiences in India where fire incidents have caused huge damage to reputations of companies. Businesses have been shut down because of these kind of incidents caused by electrical energy. So how can we avoid? Following the systematic power system design principles and frequent verification can help you avoid this kind of scenario. Unfortunately, in most of the industries, electrical infrastructure, once it is installed, validation doesn't take place. To basically bring it more on the foray, what I'm going to do is I'm going to share some case studies where active decarbonization projects, though installed and functional, were unable to deliver due to the issues in the supporting electrical infrastructure. So this typically is a case study of a 35 megawatt industrial facility, which had around 45 transformers, a network of around 45 transformers with RMUs, and also had a 5 megawatt solar plus a 9 megawatt cogeneration installed. Now this facility had 6,000 employees working in 3 shifts, so around 2,000 employees in every shift. The plant in the year 2022 faced around 7 times of tripping of their main incomer, that is our 132 kV substation incomer, due to plant side load fault. The effect was the plant lost man hours, machine hours. They also lost the generated solar energy due to this unplanned downtime. The worst part is the plant required 48 hours to restore the quality of their product. So you can imagine the substandard production must have been a waste. Please try and understand and account the carbon emission losses of these 48 hours whenever we are calculating the loss because of a downtime of electrical infrastructure. So here, the problem was that a fault at some load caused main incomer to trip as sub-distribution level breakers, EHT and MV breakers were not coordinated. It was a very small and a simple exercise. The solution was that we undertook a detailed load flow short circuit study and did a breaker discrimination study, post which these relays and breakers were coordinated, ensuring higher reliability of the electrical system. And I can vouch and I can be very proud to say that after this, they have never faced any main incomer tripping caused because of their plant load and faults. Now, we'll just quantify this to some losses or no, monetary losses as well as the carbon losses. So, if you look at the table, man hours around 2,000 employees per shift, operational time was 24 hours. We considered only 2 hours idle time. So, they lost around 4,000 man hours. The cogeneration was of 9 megawatt, so around 2,16,000 units per day. Considering that it was only non-operational for 2 hours and non-utilized for 2 hours, 18,000 units were lost. Solar generation around 4,000 to 5,000 units lost. They had a WAM system, but the data was not available, so I'm not able to share that. And product quality, as I mentioned, is something that they took 48 hours to bring to its sellable state. So if you look at this, around 11,081 tons of CO2 without considering 48 hours of production emission added was wasted. All my previous colleagues have shown about how they saved. Here I'm showing about the wasted part of it. So there's a stark difference in the picture here. So idling and ramp up energy lost with no production, increased GHG emissions per unit of production, all of this has not been accounted, but I'm sure the plant must have done that. Taking you to the next case study. This is about a reputed shopping mall in the Middle East, which with a 5 megawatt consumption, and they decided to install rooftop solar of a same capacity to help achieve net zero emission targets. Middle East has a lot of compliance. They are very strict on their compliances. There are electrical and water authorities country-wise which maintain, monitor, and ensure that it is implemented. So, post completion of installation, the concerned utility was invited to accept the facility, accept the solar generation, and allow its connection to their grid. They identified that higher harmonic distortion at point of coupling. On the day of the inauguration, they were asked to disconnect the solar power plant immediately, and they were asked to achieve first compliance to IEEE 509 2014 standard for harmonic compliances. The solar was allowed to be connected after 6 months after this compliance was achieved because the client involved us for assessment, then the solution designing, then the complexities. Please try and understand. This was a boots project, so there were 3 parties, engaged in this. One was the user, second one was the BOT who implemented, third was the integrator. So all these 3 people fighting against each other, pointing that whose problem was it. So you try and understand the complexities here. So the problem was that a facility was not compliant to IEEE 519 2014 harmonic standard even before the installation of the solar system. And the same was found by the utility while checking the installation. Now this unfortunately was not noticed, or might be it was highlighted, but the shopping mall business, the guys did pay attention to whatever it is. The solution was that we undertook harmonic analysis in compliance to these standards. We also checked EN 50160 compliance and suggested them a suitable solution for harmonic mitigation. So you look the solar generation that was lost of around 30,000 kWh per day for 6 months amounts to around 2,470 tons of CO2 being wasted. This is in addition to what energy they have consumed in their conventional manner. So what are the key strategies for enhancing reliability in working facilities? You need to validating of existing electrical infrastructure and checking reliability plus compliance to safety is a necessary thing. modernizing electrical infrastructure to accommodate renewable energy and sustainable initiative. You need to have a real-time monitoring of energy consumption and automated control of critical infrastructure. You have to have an enhanced fault detection and resolution through quick responses. Incorporating energy efficient equipment and advanced technologies, use of battery system, thermal storage, and other methods. Ensuring stable energy supply and demand balance. This is again an important part because you need to define your requirement and ensure that the generated energy is wisely used for your critical processes. So what are the benefits of enhanced reliability in working facilities? You have a greater renewable energy utilization. You have reduced operational disruptions in ensuring you are delivering more than what is required as planned, and economic and environmental advantages because of lower energy cost and improved efficiency. To conclude, I would like to specify that it is imperative to validate your installed electrical infrastructure and enhance its reliability while implementing decarbonization projects and achieve your sustainability goals. By understanding and updating infrastructure and by embracing smart technologies, facilities can certainly achieve sustainable, reliable, efficient operations, but a strong and robust electrical infrastructure will ensure that they are operational continuously, delivering their necessary output. I thank you all for this, for listening to me patiently, and I hand it over to Dhananjay to take this ahead. Thanks.
Thank you, Mr. Vijay, for sharing your practical experience over electrical system reliability and case study about decarbonization. So I once again request participant who join directly without registration to put your email ID in chat box so we can connect you and share you some more insights through email post webinar. So now when we thought of we will now move to the next session. When we thought of sustainable solution in energy, transport, or infrastructure, the first name comes in mind is Siemens. Please welcome Mr. Mahendiran Murugan, our next industry expert working in a smart sustainability portfolio with green financing by Energy and Performance Service Division from Siemens. PGDM from Bellinger Management Institute with 20+ years of diversified experience in managing key business initiatives in different MNCs. He is the key. He is involved in implementation of sustainability projects in larger scale as ESCO and manufacturing of low and voltage switchgears with smart metering. Also in electrical machineries, gensets, and automation digitization through IoT. Mr. Mahendiran working as lead in vertical focus sales pan India for automotive and tire industry. We have shared Mr. Mahendiran LinkedIn profile in chat box for more detail. Over to you, Mr. Mahendiran, sustainable engineering leader. You can please share your screen.
So good afternoon, Dhananjay. Thanks for your intro. Good afternoon to everyone. So just as introduced, Mahendran, I'm from Siemens. I'm representing the House of Sustainability Portfolio Division of Siemens from Smart Infrastructure in India. So I'll even maybe considering the time frame, I'm just quickly getting into the topic. So as you all aware, Siemens, it is known to all. We are into various products manufacturing and also the solution offering in various divisions across the globe in industry and infrastructure. And India, particularly this division which I represent right now, it is called Energy and Performance Services. So this Energy and Performance Services is we call it as the division, which is predominantly we are helping or even supporting customer to achieve their sustainability roadmaps. So again, the energy performance services in India, it is again certified by BEEE as an ISO, grade 1 ISO. And in the three areas, the major three areas we are focusing in India, it's to consulting and as well implementation of projects and as well the enhancement. It is on the digitalization portfolio and life cycle management. All these three major areas we are focusing in India. And in consultancy, I would say not only decarbonization roadmap program we are doing, but also recently we started doing BRSR reporting, like business responsibility and sustainability reporting, to be it is given by all key 1,000 customers as informed by SAB. So those activity also we are even parallel doing. So there are, I would say, there are any industry, there are two areas. One it is the process, one more it is the utility. So in our division, we are focusing more towards utility energy optimization program. That two is the major two areas. One is the supply, and one more it is the demand side. On the supply, like renewable energy inclusion, called like through rooftop solar or even ground mounted solar, battery storage, and even energy monitoring system, and even microgrid. So if you have multiple energy sources that can even be get connected through microgrid control, through which also the energy optimization can even be achieved. So these areas we are focusing on the energy front, and on the demand side, I would say the major four areas is chill water, hot water, steam, and compressed air system energy optimization. It includes storage solutions that we are even giving it in this majorly on the utility area. As well, we are also doing a lot of auditing activities. So the entire program, it is structured in such a way, it starts with an audit on which we will even offer our solution to the customer. Upon the confirmation, we will take up the projects, and those projects we will involve a lot of internal, maybe the OEMs or even internal vendors like Instron, all those people. We will even implement those projects. The entire projects can even be done in a two ways. Like one it is a capex, or one more it is the opex. So the capex means the funding done by customer, and the opex means the funding will even be supported by Siemens. It's our own company. It's called Siemens Financial Services, through which we can even do all the projects, and also the wind-up activity also we can even do it in the tenure period. So we call it as this is our engineering menu part. So on which whatever the highlighted area, so it's every area or even every solution we can even give it to customer. Like in the name of storage, electrical and thermal also we can do, and even the CHP area also we can take it. So these are all the programs we have done it in many industries in India. In larger size also we have done it. In buildings also we have even given a lot of solution in like a smaller or even a medium scale industries also we have even done it. And the HVAC system energy optimization also we have done it. Here we have our patented solution. It is called demand flow, through which the customer can even achieve 22 at the maximum 70% of energy reduction across globe. It's around 600 plus installation already is being implemented with the successful performances. In India, we have even crossed more than 120 installation as of we have completed. These are all the industry portfolio I'm just telling it to you. And in the hot water generation, now the electrification of hot waters, and even decentralization from decentralization to centralized hot water system, and even digitalization monitoring, all those things we can even do it on the hot water and the steam generation area that we are doing it. Compressed air system, it is again in a larger scale we can even do migration from slow to centrifugal, and even integration of all compressors and through our latest controller technology, that also we can even do it. And ventilation, like that is again in the fan energy optimization. Through you are all know it is now the all the AHU fan now it is migrated with the easy fan. Now we have our imported solution through which we are even we have done it in certain key industries that also I'll show it to you in a larger size on through axial fan program with the PM5 motors, that also we can even do. Lighting also we are taking it up to a company, it is called Enlighted, through which not only the controlling of energy, but also we can even space optimization and even movement detection. All those things can even be done it through a IoT kind of a product through a lighting solution we are offering. So photovoltaics, I would say like in a rooftop, we are even doing it in an innovative way, and even our payout compared to any PPA or even any developer, it is a quicker return the customer can even achieve. And even in the funding also, what we are the supports also that are like I showed you in the latest slides. And overall, I would say, so there are like that many areas, whatever it is required for your industry based on your audit, not restricted only these lines, and also if anything new technology we can even adapt and implement, that also we can even do it at your industry premises. So there are multiple areas like in that nomenclature, I would say, like energy as a service, we can offer pay. So these are all the nature of contracts. We can even explore it and we can even take it up, implement all these programs. And these are the digitalization portfolio, I would say, in a larger size, even integration of the existing system with the minimal disruption with the lesser components, we can even implement it. And even for in a larger size digitalization also, we can even take it up. That's and what are the business models? So far, what we have done shown in like in many of our projects, these are all required larger amount of capex. So there are two models we can even offer it to all industries, irrespective of the sizes. I would say these are the this first model, we call it as a managed service agreement. So this has its own benefit, wherein the entire funding done by Siemens, and it is the savings the customer can even pay it from their sorry, the rentals the customer can even pay it from their savings, and it is a zero investment. Typically speaking, there is no investment from the customer. Entire 100% investment will be done by Siemens, and the savings also, whatever the numbers we are even confirming on the savings fund, that also will guaranteed one. So this is again one model, only certain states where we can even explore it. Tamil Nadu, Karnataka, Maharashtra, and Gujarat, Delhi, and Haryana. These states we can even explore it. So and the one more model, it is the kind of a loan or a lease model that also can be explored in a tri-party kind of agreement. Rest of the states in India that we have done it. And what are the benefits by doing this kind of a business model? So there are, starts with the benefit, I would say that there is no collateral. These are all the funding will be extended by Siemens without any collateral. And for it is basically speaking, it is an off balance sheet model. So the customer no need to maybe carry the liability on their books. So this will be done by Siemens itself. This is one area. And whatever the rentals are, it is a fixed one, and the customer can that way the model will even be arrived, so that there will be no problem on the payouts. So this and all we can even do it, and with the minimal documentations we can even do it. So, but we'll not even extend it to the maybe the kind of all industries based on the credit score and based on the credential the customer has. For those customers, we definitely we can even extend this kind of supports. And where and how we have done it. So actually, it is an tire industry in South, where this with this finance model we had removed, or even we had even is around 50 plus fan system internally in the premises that is even being removed, and also the energy optimization it is being done. The customer right now they are enjoying the benefit of around 54% energy savings, which is coming to the tune of 2 crore per annum. See the entire it's around 6 crore project, which is funded by Siemens, and there is a 5 years model. So this is again one industry where we have even done this kind of a finance model with the energy optimization program for the AHU's energy optimization. And it is again, there's one more industry, I would say, like it is in a pharma company. Whatever the programs, yeah, I had even shown it in my menu card. So all programs we implemented in this slide with the OPEX model with the 5 years as a finance contract. So the customer benefited is around 41 lakh unit, sorry, 41 lakh unit per annum to the tune of 3 crore energy in the cost, I would say. Savings it is achieved by the customer, and it is funded by Siemens only. So with the simple payback, it is a 3.3 year. And if it is, since we have funding the project, this is again increased to 5 years. And there is one more company. So like that, I have many, we have many reference cases. Only key cases only I'm just highlighting it here to get an feeler about our program and what and all we have done it in industry. It is again whatever I have even told you, like demand flow chill water energy optimization system. It is a patented technology we have implemented in a car manufacturing company in India. The customer, the overall energy savings, it is 1.7 crore per annum they are achieving in the tune of 1,400 tonnage of carbon emission reduction they are achieving year over year. This payback also it is within 1.5 years. It was coming. And in that same way for the hot water generation. So hot water, this is again one more tire industry in India, where they were producing the hot water through the electrical heater, which is again replaced by our innovative solution. It is a high degree. It is the machine what we had even given it to the customer. It is a 120-degree hot water generating heat pumps with the water source. So the customer has achieved in that dual benefit. It is one, it is the hot water it is generated with a lesser energy consumption, and the overall chill water loading also has come down to 15%. The overall gain for the customer it is around 60 lakh rupee per annum, and it is the energy, the CO2 reduction also they are achieving within the tune of around 630 tonnage per annum. And the storage also we are doing it in larger size. This is again one reference case which we have done it in our Goa factory for to store the chill water and use the chill water only at the time of high tariff hours. So through which we are even gaining two things. One, it is the cost optimization has been achieved, and as well the carbon emission achievements also. It is around 1,000 tonnage carbon dioxide emission per year we have achieved, and even it is around 1 crore per annum. This is what it our energy cost savings is achieved. And it is one more project. It is in the name of renewable energy. We have done it in the industry, competing PPA with and we offered our model through our O&M. That means boot model we call it as build, operate, and maintain. Through this model, we have developed the project, and with the overall unit rate, it is 3.8 rupee. It is the achievement, and again the payment tenure also will be within 10 years. So actually, this is this model we had even explored it in the first time in India, and after that it is picked up, and also we are right now we are even executing it is put the case in India. Right? And not only this, we are also giving a lot of EV infrastructure systems also to various industries. The charges, the entire charges, it is our own ranges. We can even give up to 600 kilowatt the chargers, and even this model also can even be developed end-to-end solution, including electric infra plus charging infra. The fleet only customer has to prepare. Remaining everything can even be funded by our suppose. So this program also we can even do. And this is again our digitalization portfolio snapshot. It is again whichever the project when we are implementing, this is will come as a added benefit to customer. And why Siemens? The overall, whatever I have even shown, it is almost 70% of areas it is bought out. Only 30% of those products only is manufactured by Siemens. But still, the Siemens, we are even successful in doing this kind of business some years ago. So the reasons are, it is clearly speaking, it is what we are even doing, it is an end-to-end solution. We take it up with our funding support and to achieve the customer to reach their energy optimization goal. So this is what it our overall program. And in Siemens, particularly in this division, we do the entire consultancy to creating a roadmap and as well giving a lot of value added benefit and all those things. And the entire planning and design also will be done by Siemens. Implementation again done by Siemens. And operation and service, including maintenance, is the recent addition of Siemens portfolio that also we can take it up, and as well as success monitoring. It is we call it as a MN, measurement and verification through digitalization portfolio. So this also can be done. So if you go by Siemens in this division, particularly energy and performance services in India, we are successful in delivering our results in many industries.
Thank you, Mahendran, for
Yeah.
your nice presentation and insights on the Siemens EPS portfolio, working to make sustainability as a focus.
Thank you. Thank you.
So having come to an end of our section in which our experts have shared their insights on how to reduce the carbon footprint and increase the efficiency. So I request to share our screen so that audience can get our contact details, so they can connect with us. And now we can start a question and answer session. So you can drop a question in the chat box, and then you can raise your hand. So we will discuss. There's one question already received on the email that we are going to take first. This is how can we check electrical system reliability of a facility? Is there a way to identify it? So I think this is question for Mr. Abhijit. So
Yeah. See, the best and the most easiest way to identify whether your facility is reliable is to check its compliance to applicable electrical safety standards. Let us take the scenario of a facility in India. The Central Electrical Authority has very well defined the electrical standard requirements for facilities in India. And today, I'm proud to say that our electrical safety regulations are at par with whatever is happening globally. So it is not just we are trying to be a global manufacturer, but we are also at par with their the standards and the electrical safety requirements for facilities. So once if we are able to identify and validate our facilities electrical infrastructure safety compliance, automatically I can assure you that you will be able to understand where we are standing and how we can make it reliable, because reliability and electrical safety are basically the two sides of the same coin. We have this has been identified, we have seen it, we have more than 100 plus or cases where just by achieving compliance the facilities the reliability has gone increased multifold, and they have stopped facing any kind of issues.
thank you, Abhijit.
Thank you.
Thank you for explanation. So I request all participants. So we have placed one feedback form in the chat box. So I request to click on that form and provide your valuable feedback. So there is one more question. Sanjay sir, please continue. Please ask your question.
Yeah. Good afternoon.
Good afternoon.
Good afternoon.
Yeah, actually, I have worked into various companies, and the problem the company usually asks the proposal for energy conservation is that it is basically the cost, it is into the percentage, how much cost you save, and accordingly the percentage of the and that fees will be provided to the service provider, because we many times we give the proposal for the energy conservation, and in the case of air, as you mentioned, I know that there are a lot of opportunities in the companies, but when we go with the companies, they ask that give the proposal, and your fees will be in terms of the savings. So how we can satisfy the customer in that case?
See, if specifically if we speak for compressed air system,
Yeah.
see, rather than going ahead with bigger investments, you can identify and you can then prioritize what could be, once the assessment is done, system assessment is done, you identify in compressed air system that what are low hanging fruits. In 90% cases, you will find that out of the total saving, around 40% saving is done by either zero investment or very minor investments, which can be recovered within 6 months and which can be allocated from their maintenance budget itself. So what we can do is, yes, definitely, see, the technology comes in picture when there is any replacement, and the highest cost of replacement in a system is compressor itself.
Right.
But in totality, if you look at the system, like as piping replacements, some monitoring systems to be installed, and some leakage identification and reduction of those, demand assessment. So these are all low key and low hanging fruits which can be implemented. So we can go in both the ways. One would be the ESCO model, wherein end-to-end solution can be done. And if the customer wants financing, we can help with the financing also. And with the pre-audit data and with the data coming after and the implementation, that is the verification, can also be done easily. So financing, more precisely your question is on the financing part. So we can do both the things wherein we can arrange for the financing, we can help implement, we can reduce, we can prove, and then definitely then only the customer will start paying out.
Okay.
Thank you, Virendra ji. Thank you, Sanjay sir. So next question from Nilesh K. Sir, are you conducting energy audit for ISO 5001 certification? So I request expert to answer this.
Yeah, basically, we can undertake audits for ISO 50001 certification. That is typically a continual energy efficiency implementation program. So this engagement is not just a single audit, but it engages entities for a longer period of time where within all your processes are audited for energy optimization. And also one of the important things is that you need to even look at their procurement procedures, where when your systems are being procured, whether we are looking at a what kind of a payback, how energy efficient it is, what is the CO2 emission. So if an organization is willfully willing to go for ISO 50001 energy optimization program, we can certainly be of help.
Thank you, Abhijit sir, for answer. So I once again request a participant to please give the feedback through that feedback form shared on the chat box. It will be very easy. It will take not more than some seconds to fill it. So there is one more question come to us. That is, do you know the cost involved with your compressed air system? So this question again for Mr. Dhirendra.
Yeah. So as discussed during the presentation, many people, whenever we operate a 1 HP or other 1 kilowatt air conditioner at our home, we know the bill, that what is the bill, monthly bill is going to be when we run air conditioner for 8 hours. So if we are operating a system which may be 250 kW, in some cases it can go as high as 2000 kilowatt as a whole, a continuous load in a plant. So many people just don't know the cost involved with compressor system. So if you say, I could give you a few examples. Earlier in presentation also, I gave you example of a 250 kilowatt compressor consuming ₹1 crore in a year just on the electricity cost. So in most of the cases, there are some few thumb rules for compressed air system. And if you say, I will give you, I'm just calculating these values at ₹5 per kWh, which are just not prevailing now. It would be ₹9 or ₹9.5, or in some cases, like I said, when you go in Goa area, it would be 11 to 12 rupees as well. So if I'm just giving you an example of a 90 kilowatt compressor running throughout a year at ₹5 per kWh, so it will consume around 31 lakh rupees of electricity bill. So you can just imagine how costly running a compressor system is. So if you are not efficiently monitoring it, if you are efficiently not auditing it, if you are efficiently not using it, the cost will keep rising and rising. And there are many parameters. Generally, when we say if you are not sitting in our office, we generally don't run the air AC. Similarly, when we are not using compressed air in plant, during that time also compressor runs on unload mode. So running a compressor on only unload mode 4 hours a day, when the compressor is not delivering anything, but only the motor is running, 1.3 lakh rupees will be just gone only in running in unload mode. And basic thumb rule for compressed air system is, for every 1 bar extra pressure you are generating or supplying to the user, which does not require, you are increasing your operating cost by 7%. This is basic thumb rule. So always keep in mind, if any user at your plant is asking that please increase the pressure, please make him aware that increasing that pressure by 1 bar, how much it is going to cost. Is it going to help in his production, or rather it is just only to fulfill his need that, okay, some user has told me or some manufacturer told me that my machine requires 7 kg pressure, and unnecessarily he is consuming 7 kg. As such, in many cases, we find they will be having regulators where they will be reducing up to 4 bar.
Thank you, Dhiren sir. There is one more question from Mr. Mustafa Abdul. This is for Mahendran. Mahendran, please unmute yourself. Does Siemens have a solution for carbon capture from a cement production facility?
What facility it is? Please come again.
Cement production facility.
Cement production facility, what kind of a solution they require?
So they are asking carbon capture, solution for carbon capture.
Yeah, that shall be, yeah, surely we can even explore it, yes. So what they are even asking CCU,
Okay.
yeah, that shall be done, yes.
So, okay, the answer is yes. So for more detail, you can connect.
Yeah, you ask them to connect me so that.
Yeah. So, Mustafa sir, you can connect with us. So we will surely for the more detail, we'll connect with you. So that is the last question I'm able to see here. So this is for Milind. So the question is, you are talked about the IoT system. Can you more elaborate about the decarbonization and IoT OT?
Yeah, hello. So I think it's almost towards the end, and then we heard about this interesting question. It's like earlier we used to have this offline system, and then the inefficiencies were there in the plant, and then at the end of the day or a month, you used to see a bill, and then that's when you used to calculate, okay, this is my efficiency or inefficiency, and how much I have lost in terms of the tons of CO2. Whereas the IoT system, if with the help of IoT systems, is like within the few minutes or seconds itself, you can alert your operation team. And this can be done by installing some additional sensors, like for boilers, it could be a stack emission sensors. For paint shops, it could be the excess O2 sensor. For the ETP plants, it could be the pH and conductivity. So all this kind of sensors can be selected by our experts. It can be installed, configured, and based on that, the real-time deviations can be given to the users. And thereby, the users can reduce their potential losses, not only in terms of the quality, efficiency, but also in terms of the CO2. And that's how the real-time monitoring, coupling with the productivity, efficiency, safety, along with the environmental aspect, will help the customers to achieve this benefit with the help of this smart systems like the IoT systems. I hope I could answer the question correctly. Thank you.
Thank you, Milind, for your clarification. So with this, we come to our end of our session. So I thank you for all the industry experts for sharing their views on the decarbonization, and as well as producing the case studies which helps our participant to understand how decarbonization with efficiency will help them in the industry. So I also thank you organizing this nice webinar by Sneha and the team and our marketing team. We will bring you the another new exciting session in the coming months, and we for this session you will get the recording as well as all the details on your mail ID. This will be shared by Sneha. Sneha also will in connect with you for the more feedbacks and for more question if you have any. So thank you all for joining us, and thank you very much. Okay, there is a feedback, Costa. Yes, sir, we will share the recording definitely to you. Please put your email ID in the chat box if you are not registered. So those who are not registered, please put your email ID here so we can share all the details to you. So Costa, can you put your email ID in the chat box? Okay. Thank you. Thank you very much.